All right, hey physics class, let's talk about breaking angled vectors apart. So what that means is, let's say we're gonna actually look at a vector. Let's say we have, let's say we have a car. We have a car. Here's my fun car. All right, it's got some wheels. It is going this direction, okay? So let's say it is going, I don't know, 21 meters per second at an angle of 55 degrees, okay? So it's actually going to be, it's driving at this certain direction, it's got this magnitude, 21 meters per second, and it's got an actual angle. So it's got some direction, and we can say that it's going, again, north of east, okay? So north of east. Now, let's actually break this into two different parts. I want to know how fast, technically. And the reason we're going to be breaking this apart is because eventually we're going to be having things hit each other or crash into each other or collide with something else, or something else is going to hit it. And we're going to have to know what kind of very X and Y directional forces we have, especially if we have things working against gravity as well, okay? Because gravity only goes in one direction, so we're going to have to maybe break some things apart directionally. So let's bring this into an X, and I'll use a different color, and a Y. Okay, Y and X. So I want to know basically the speed that is going in just the X direction. Like if you were to just be standing looking at it going this way, how far is it going that way? And how fast is it going if you were standing here? How fast is it going just that way? All right, so we can do that by, again, using our trig, okay? And if you were in my live class, you kind of saw that we broke it down this way. This is our adjacent. So when we're doing SOHCAHTOA, we have our adjacent, we have a hypotenuse, we have an angle, so we can go cos. Anytime you're trying to find an x component, we're going to go cos theta multiplied by our hypotenuse. And if we're going to do our y, that's our opposite from our angle. We're going to go, how do we get our y component? Sine theta times our hypotenuse. Okay, so let's actually figure this one out. I haven't done the answers yet. I got a calculator here, so let's go through this. So hopefully you guys see the same actual answers as I do when I go through this. Let's do my x component first. So I'm going to cos of 55. That decimal gives me like 0.5735, that's okay. Times it by our actual magnitude, 21, okay, our hypotenuse. So in the x direction, it is traveling at a speed of 12 on the dot, basically 12.0 something. We'll just leave it at our whole number, 12 meters per second. So if you were to watch it just going this way, because I mean, if you were standing here, it's going to be hard to tell how fast it's going this way. It's moving away from you, so it's not that easy to tell. But you would be able to see it moving 12 meters per second, kind of going sideways. Okay? Now let's do the y. The y, again, we're just going to go with our sine function. So if I go sine of 55, get a decimal of like 0.819, and I times that by 21, our hypotenuse, I get 17.2. So this is 17.2 meters per second. And that's just in this direction, our north direction. Okay, forgot to kind of do this. This is our east direction. And there you go. So that's our actual breaking apart. And I get this all the time from other physics students. Like, it looks so crazy. If I go 12 and 17.2, that looks like it doesn't come close to that. Well, it's not exact adding up. And the other thing is, if you actually check your work right now, and do your a squared plus b squared, it's going to work out. I'll do it here right now. So we go 12 squared, gives us like 144. 17.2 times 17.2 gives us 295.84. If I plus 144 to that, I get something like 439. I want to do the square root. There we go. Square root of 439.8, I get 21, or for this one, 20.99. But basically exactly the same thing, 21. So this is how you break apart just into different actual pieces. And whether it's an acceleration, a velocity, a force, a distance, it doesn't matter. As long as you have a magnitude here, to find your x, cos theta times that magnitude, and for our y, sine theta times that same magnitude. Okay, class, thanks much.